This video will be about this new robot toy, single motor robot toy I've designed. It uses the same Picaxe or A-Tiny board as the last one I designed and released, using either an A-Tiny or 85 or a Picaxe 08M2 board. The only difference is the board doesn't use these headers. They come out the back on this version. The basis of the design is this one-way or one-direction clutch mechanism or ratchet mechanism. I'll show it using a switch box that drives the motor in forward or reverse. When the motor is driven in one direction, they both go in both the wheels will spin in the same direction. When the motor is driven in the opposite direction, one wheel will be driven one direction and the other in the opposite direction. So this would be forward, this would be spin. Forward, spin. It's based on this ratchet mechanism. I've showed it in another video, so I won't go into too much detail here. I'll try to get a little bit of it here. The way it works is that one of the wheels is driven directly from the bevel gear here. I believe it's this one. So this bevel gear drives this wheel directly, so it will drive so it will be driven straight from this. If the motor runs forward, it'll run in one direction. If the motor runs backward, it'll run in the other direction. This wheel on this side will be driven from this inside ratchet assembly. When the motor is run forward, it will run in the same direction as this side. When the motor is run in reverse, it will run in the opposite direction. This switch box can also be used. You don't have to use the microcontroller control board and IR control for this. You can just use this switch box and run it through a hole in the back. If you just want a wired remote, that would work. I'll show the wiring of the switch box later on. Just another quick demonstration of it. Now I'll try to show how it's built. These are the parts we're going to use. This is the body. It gets printed with supports. This blue thing is called the head. The yellow thing inside is called the inner globe, and it is what holds down the PC board if you go the infrared control route. This is a 50mm Christmas tree ornament globe, half of one. They mount on the body like this when it's all assembled. Here are the internal parts. To start building, we're going to need the left wheel and the left spur or bevel gear. We're going to attach the left bevel gear to the left wheel. They're marked L on each side. To do that, get them started the best you can. I've made this arbor to put on there, and you can tap them together with a hammer. They should fit flush. This is supposed to be a permanent connection. They're not supposed to slip against each other. If you have to, put a very small amount of super glue on it, but don't get carried away because you'll gum up the works. That's the left side. The right wheel is attached permanently to this 57mm length of 1/8 inch brass rod. I used a drill press, mounting the shaft in a drill press and pressing it down like that to get it straight. Although I have used a hammer and just pounded it in and got it to work, whichever method you can make work. But this shaft is securely attached to this wheel. They don't spin. The right bevel gear is attached to this spacer. You put it on there just like this, and then use the arbor to pound them together. Try to get them as flat as you can. The next thing we have to do, the hole in here and the hole in here has to be big enough to spin freely on this shaft. Now they will not, so we have to drill those out. To drill them out, you use an 1/8 inch drill. I just been doing it by hand. The main thing is to get them started straight. You could also do this on a drill press if you have it. It'd be much easier. So after you get it started, spin it and make sure it's you're going to want to drill this out so that it spins freely on this 1/8 inch shaft. So however many times you have to pass that drill through it to get that done. I'll probably go through it a couple more times. Should spin freely. You do the same thing to this side. The other bevel gear, the right bevel gear. I've got a little wobble in there. We'll see how that works. You can take your time and do it right. Again, it has to spin freely on the 1/8 inch shaft. Maybe too much wobble, we'll see. Just might not have it pressed down there good. Okay, now we have these two parts done. The other two parts we need to assemble this mechanism is these ratchet, or that's what I call them. They will eventually go in on the shaft like this. These are what selects which side drives the wheel. They have to fit on the shaft fairly securely. I'll glue them on in the end, but to get them to where we can do some adjusting on it, we'll probably have to drill them out with the 1/8 inch drill again. You need to be careful when you do this. Don't hold this on this finger, it'll break off. You can reprint some more if you mess them up. It's not that big a deal. Again, get them started. Try to see if you can get them started straight. Drill it out just enough so that they will slip on here, and you can move them. They don't have to spin freely like the wheels. Oh, and there is an L marked on one of these that will eventually be assembled on this side. The L's all go together on the side. So we'll drill this one out. Just enough to get it on the shaft. Now that that's done, we need to assemble this plate called the caster plate to this called the frame. when you print it, there is a sacrificial bridge in here. If it has to be drilled out, where the screws go. So run the drill in the right direction, it'll work better. Now this will be super glued like this to the caster plate. There are embosses, I guess you would call, raised portions that will locate it. I'll get the super glue and glue that in. We'll wait for that to set up now. I think the glue is set up on our frame to caster plate assembly, so let's assemble this and put it together. First we have the right wheel with the 1/8 inch shaft permanently mounted. Next we're going to put on the right bevel gear. First spinning freely. Next we're going to put on the right ratchet, the one that's not marked with the L. Next we're going to put on the left ratchet, the one that is marked with the L. We should interlock right here. Next we're going to put on the left wheel and bevel gear. Now we have to permanently attach the ratchets to the brass shaft. To do that we just need to make sure we've got a little slop in it, but it will still fit in the frame. Do some adjusting. Probably the best way to do this is just to open that up a little and then put the super glue on it. Here's the super glue. Don't get too carried away, especially if it's thin super glue, it'll get everywhere. This is a little thicker. And then press them together. Hopefully it should still spin freely. Probably not the best way of doing things, but that's the way it is. Now we'll let that dry. We can go ahead and assemble the rest of it though, I think. Put the left wheel back on. Now this assembles this switch pocket where the switch will go is in the front, and the left and right is referenced to the front. So right here, the left will go on this side. Switch pocket here, left here. Now we can we have to this is part called the clamp, the frame clamp. We have to get our motor in there though. We also have to get the top bevel gear in right there. And there is a small spacer, this little guy, that will fit on the motor shaft between the motor and the top bevel gear. I'll get all that lined out. There's our little N20 motor. I believe this is 160 RPM, I believe. Put the spacer on there. The gear goes on here. There is a key on it. It shouldn't go too deep. I'm not sure if a spacer is necessary. I can't remember. It's been a while since I designed that part. Put the motor in the frame clamp. And put it together like this. With the motor pushed. We'll put some 3mm by 12mm machine screws, whatever you got that'll fit in there, to hold the frame clamp to the frame. Push that motor down. I think right about there is where it goes. You need a little play down here. Once you get this in the right place, you'll just stick a little bit of hot glue on there. Now I'm going to test it with that switch box that I showed at the start, so I don't have to hook up the electronics just yet. We have our switch box here. Put the tires on it and see if it works. These are just O-rings from a Harbor Freight O-ring kit. I just picked ones that would fit. Forget the inside diameter, I wrote it in the description. Let's see if it'll move. Okay, we can do one other thing. There's a little part in here, I think I printed it, called the caster. It just pokes in here. Probably have to super glue it in, it fits kind of loose. I'll go ahead and do that. I've super glued the little caster onto the bottom of the caster plate. And when there's a battery on here, if you run it with a battery pack, I'll show that in a minute. It'll be weighted on this end, and it'll keep it level. If you want to run it with a switch box permanently and not use the IR control board, you just have to put some weight here. To show how the rest is assembled, I'll just take apart the pre-built one. There's a Phillips screw right here holding the globe on, the clear globe. This is a 3mm by 8mm screw. This inner globe also clamps the PC board down. There's two screws here. There are 2mm by 8mm plastic screws, self-tapping screws. And here's the PC board. It's the same PC board, either the A-Tiny version or the Picaxe version as this. I did make a little standoff here from some female DuPont headers where I soldered the IR sensor on, but this would also work if you just probably wouldn't even have to bend it back, but left it sticking up a little and bend it back a little. The main thing about the board is instead of headers coming out the top, there's no room for that and no power switch. I just put a 2-pin header and then a shunt across it for the power, and then a power switch down mounted on the caster plate. Instead of the headers mounted on the top of the board, the headers for the motor come out the back, and they're angled slightly downward after they're soldered in. So if the wires feed up from the motor and hook up right here, the motor connectors, you would just have to play with the polarity until you get it to work right. The battery connector, however, the polarity is very important. The board on the bottom is marked ground and VCC, so you have to make sure you get the wires in the right place. So that's how the board hooks up. Otherwise it's the same as the board on that last project I did. Don't make your wires too long. Make them extend up about this much so you can get them stuffed back down in the body. To take the body off, there are 3 screws on the bottom, 2mm by 8mm screws. There's the body with the little arms. The arms are made in 2 halves. There are holes in them for assembly. You just take a piece of 1.75 filament, PLA filament or whatever you got, and use them in the locating holes to hold location while you glue the 2 halves of the arm together, and you just glue the arms on here. There's also another version of, if you don't want arms, you can use this little thing. It's made the same way. It's like a little laser blaster or something. Mounts the same way on the body. Both of them will be included in the STL files. Like I said before, this head is glued to this body. The arms are glued to the body. There's not much meat on this screw hole over here, so that's just the way it worked out though. This has to be printed with supports. The body does. The battery pack is a three AAA batteries. When you to mount the battery pack onto this frame, you just use a piece of single-sided or double-sided tape on the bottom. Not here, there won't be enough room. It just sets up against there. Once you get the thing assembled, nothing's going anywhere. The switch is in front. It's a, I'll leave a link to the switch in the description. It's a very small switch. This gets hot glued in after you get the wires run. Take your positive wire, run it through the switch and back up to the power connector on the board. The 2 wires from the motor, just keep them about that length so you can stuff them back in the body. The ground wire from the battery just goes straight to the board. We could run this one on a battery pack too. Hook the motor up here. That's what's inside. It's pretty simple. Well, I've got it back together and working. Here's the schematic for this little switch box I made. It's pretty simple. We have a battery box down here, 2 single pole double throw switches up here, momentary contact switches like micro switches. The wiring is the common from each of the switches goes to a motor. So one to one side of the motor, one to the other side. The 2 normally opens from the switches are tied together. The 2 normally closed from the switches are tied together. Then from the battery, one of the wires goes to a normally closed and one of the wires goes to a normally open. And that's all there is to it to get it to work. To have a reversing forward and reverse controller. This is a, I believe, a 3 AA or 3 AA batteries or 4 AA's. Any of that should work. 3 to 4 cells, AA or AAA. I'll put all the files on Thingiverse, and see, I'll also put them on Prusaprinters, which seems to be a little more stable site. The files for the circuit board will be on a GitHub page with the code. It's the same as the board I used last time, so all that's the same. You can go to Easy EDA and zip them up yourself and to order the boards, or just use the zip files on the GitHub, or the files on the GitHub page to order the boards from wherever you want to order them from. I believe that's about all there is to it. A 3D printer needs some tuning, I believe. Well, thanks for watching.